Rectangular versus polar coordinates. Rectangular or Cartesian uses a horizontal x-axis and vertical y-axis. To locate a point such as 4, 3 means to start from the origin where the axis cross, then go 4 units in the x direction, and then 3 units vertically upward. This is for rectangular coordinates. Polar uses different setting. It uses a horizontal x-axis or r-axis. To locate the same point as above, which is 4, 3, we use its distance from the origin, which is r. R is the distance x squared plus y squared, so r is 5. And the angle, we would rotate anti-clockwise from the x-axis. So we can calculate the angle by using the formula tangent theta equal to y over x, which is 3 over 4. So which with this amount of angle. So now the coordinates in polar coordinates are with 36.9. So this is the direction, and the distance from the pole is 5. 1, 2, 3, 4, 5. Why we use polar coordinates? Polar coordinates are often used in navigation, such as the destination or direction of travel. Okay. Example, the marine police receive a distress signal from a unit of their ship. The signal comes from a Cartesian coordinate 3, 3 as shown in the following figure. So dia terima signal 3, 3. This is the police, and this is the location of signal at the coordinate 3, 3 at the rectangular. By using rectangular coordinates without the knowledge of polar coordinates, the police need to move 3 km to the east and 3 km to the north, right? To reach the location. However, the route is not the best one. The police can move quickly if the location is given in polar coordinates. Means that the police can go straight away to the location. Okay. If the coordinate is transformed into polar r theta, we will get this value. It means that the police need to move 4.24 km in the direction of 45. So dia boleh pergi terus ke tempatnya. Another motivation why use polar coordinates. Suppose you have a set of data that taken out from experiment. Both Cartesian coordinate and its polar coordinates are plotted below. The same set of data, in Cartesian you will get this figure, and in polar you will get this figure, heart shape. Okay, so in polar coordinates sometimes the curve is more meaningful. Okay, the more meaningful. Now we want to do example 10. Convert the polar equation, okay, to rectangular equation. So when you want to convert from polar or rectangular, you need to remember the formula. There are 4 formula. You can always refer to mathematical formula book, which is x equal to r cos theta, y equal to r cos theta. Okay, this first two is for obtaining xy, to obtain rectangular coordinate. If you want to convert to polar, you must know another formula, which is r square equal to x square plus y square, and tangent theta equal to y over x. Okay, so it depends on the problem. For this problem, you have this equation r equal to 2 cos theta plus 2 sin theta. Okay, this is polar. It involves r and theta. The variables r and theta, so this is polar equation. We want to convert into rectangular equation, rectangular that have x and y variable. So how to change this expression into polar? Based on this formula, x equal to r cos theta, do we have r cos theta here? No, not exactly. Do we have r sin theta? Sorry, this is r sin theta. Do we have r sin theta? No. So how to make our equation so that we can replace by using the formula? So you have to multiply by r. Why? We want to add r for each term. So you will get this form, r squared equal to 2r cos theta plus 2r sin theta. So now you have r cos theta. So this bunch can be replaced by x because x equal to r cos theta. And also you have r sin theta. So this bunch can be replaced by r. And for r square, this one can be replaced by using the formula x squared plus y squared. So we replace all to the left hand side and to the right hand side. Now your variable has no longer r and theta but x and y. So you are good. So this is rectangular form. Okay. So this is the transformation of equation. Number 11, convert the polar equation r sin theta to rectangular form. So the equation is r sin theta equal to 2. We are still using the same formula here. Right? Okay, find the one that can be replaced by r sin theta. R sin theta, here we have y. So this bunch of expression can be replaced directly by y. So on the left you can write y, on the right remain as 2. So this is the answer, the rectangular form. Okay. Convert the polar equation to rectangular form. So for this case, r equal to 2 cos 2 theta. In our equation, we don't have this formula that relates to double angle. We are still using this formula for conversion. This is the basic rules. Okay, we will apply this. Based on this formula, no angle has 2 theta. Every angle cos theta, sin theta only, not cos 2 theta. So you must convert this double angle by using the formula. So by using double angle, cos 2 theta can be represented by 2 cos square theta minus 1. Then we can try to expand this like this. Okay, so this is your formulation. Cos theta means you have to repeat multiplication, right? Cos square means cos theta times cos theta. So this is your current formulation, and you want to apply the transformation rules in order to get y and x equation. So here we have cos theta, so we miss r. So what to do? You just need to multiply every term by r. And here we also have we need another r times r again. Okay, so now you will have r to the power of 3 equal to 4r cos theta, r cos theta minus 2r square. So here for each r I put close to r cos theta, so that we know this whole bunch r cos theta can be replaced directly by x. This is can replace by x. Okay, r square can be replaced by x square plus y square. R power of 3 can be replaced by r square times r. Okay, so r square is x square plus y square times r. R is x square plus y square square root. So the left hand side becomes like this. For the right hand side, you can change to 4x square minus 2x square plus y square. So this is the final solution. Okay, next concept is the distance in polar coordinates. How to calculate the distance? Let D denotes the distance between 2 points in polar coordinates, denoted R1 theta 1 and R2 theta 2. Then, to calculate the distance, we use cosine law. Here, D square equal to R1 square plus R2 square minus 2R1 R2 cos theta 2 minus theta 1. Okay, this is the formula where R1 and theta 1 is the first point, R2 and theta 2 is the second point. This is inspired by cosine law. Okay, why we have cosine law? Look, the first point is R1 theta 1. Okay, this point. The distance from the pole is R1 and the amount of direction is theta 1. Here is theta 1. The next point, R2, the coordinate is R2 theta 2. Another distance from the pole R2 and the angle from 0 is theta 2. So this whole thing is theta 2. So you can measure this angle only with theta 2 minus theta 1, right? So this is the angle. And you have D, you have R2, R1. So if you want to redraw with a clean version of this, what we have here is, this is D, R1, R2, and the angle is theta 2 minus theta 1. By using the cosine law, D square equal to R1 square plus R2 square minus 2R1 R2 cos of this angle. So this is the formula. Let's solve question 13. 2 points are specified using polar coordinates. Find the distance between the points. So we can denote the first element is R1 and this is theta 1. This is R2 and this is theta 2. The formula of finding distance, D square equal R1 square plus R2 square minus 2R1 R2 cos theta 2 minus theta 1. R1 square is 2 square, R2 is 2 square as well, minus 2 times 2 times 2. Cos theta 2, 11 pi over 6 minus theta 1. And you have to perform the calculation. You can simplify it. Equal 8 minus 8 cos 9 pi over 6. And then it is equal to 8 because cos of this value equal to 0. You need to find D, not D square, so you have to put the square root. Your final answer is 2.8284. So that is the end of topic 7.3.